So now as we continue our discussion on the Hardy-Weinberg conditions and looking at things that are necessary in Hardy-Weinberg and the things that are actually seen in reality, we're going to entitle the next flowchart Continuation of Hardy-Weinberg Conditions, and we'll say Roman numeral 2. So Hardy-Weinberg Conditions 2, and this one is going to be devoted to the condition number 3 in our previous flowchart, which we said no natural selection. So you know what we're going to do. We're going to see what happens if there is natural selection, just so that we understand why we don't want natural selection in a Hardy-Weinberg population. So let's look at natural selection, something you should be quite familiar with, but it's just important to look at one more time. Natural selection, if you don't already know, and hopefully you remember this for the rest of your life, its definition is that it is simply the mechanism of evolution. Simple three-word definition. This is how evolution happens. Natural selection is the mechanism of evolution. And based off of this knowledge, we have an assumption that Hardy-Weinberg makes. The population, let's say, the Hardy-Weinberg assumption is a huge assumption that states the following. In a Hardy-Weinberg population, intuitively, we are stating that all individuals, all individuals have what we say an equal. All individuals have equal. Let me just differentiate this, make a line here. All individuals have equal ability to produce, what do you think? The whole idea is offspring, to produce not just offspring, but viable, meaning healthy, and fertile, meaning offspring that has the ability to produce their own offspring, Viable and fertile offspring. This is a huge assumption. And do you think this is seen in nature? Do you think this happens? All individuals have equal ability? Absolutely not. This is not what's seen in nature. So what we can say is that whenever we're talking about natural selection and why we need no natural selection, there's a huge problem with the idea of natural selection actually being seen in populations. There's a huge problem with natural selection that Hardy-Weinberg does not want to deal with, that this perfect scenario of Hardy-Weinberg says no natural selection, absolutely none. Why? Because there's a problem, and the problem is the following. If we have natural selection, then what we have is what we call variation, of course, and this variation among individuals exists very, very much so. Among INDS for individuals exists. This is not good for a Hardy-Weinberg perfect scenario, because what happens is, just like we've been alluding to, is that some individuals become more successful than others, right? That's what happens in a Hardy-Weinberg scenario. In a natural selection, non-Hardy-Weinberg scenario. Some more successful than others at the two most important things all of life is devoted to. What are they? Surviving, survival, and reproduction, right? Some are better than others in a natural selection population, in a population that has natural selection, which is every population, because they have this ability to survive and reproduce better than others. Some individuals because of their variations. Hopefully that's very, very clear from our Darwinian evolution discussion. Darwin, he himself, would refer to this as the idea of, in quotes, differential reproductive success. A perfect way to summarize everything I just said. Differential reproductive success. Some are better than others at passing on their genes because some have variations that are better than others due to natural selection that allow for survival and thus reproduction. Differential reproductive success is a direct influencer that alters, that easily, and we know this for a fact, alters allele frequency. It absolutely alters allele frequency in next generations. How do you know that? Well, that's because the people that have the allele frequencies that are non-favorable, the variations that are not good, the variations that do not promote survival and do not promote reproduction, they will not be seen as much in the next generation. You have altered the allele frequency. What is Hardy-Weinberg all about? Looking at the baseline in which nothing is changing, in which we have the constancy of allele frequency, the constancy of genotype, you have thrown all of that out the window when you involve natural selection because it's such a powerful mechanism. Thus, if you have the alteration of allele frequency, final statement is that you can say that the population is indeed not, absolutely not, in HWE for Hardy-Weinberg equilibrium. Okay, because in Hardy-Weinberg equilibrium, what do we want? We want constant AF, allele frequency, and constant genotype frequency, GF. So that's our big problem. And last statement about natural selection is that, and this is something we already know, natural selection eventually leads to what we refer to as adaptive evolution. Very powerful tool leading to a very powerful result called adaptive evolution, in which we have the idea of the alteration of allele frequencies so that the beneficial traits, those alleles, those genes are going to accumulate in the population because they are beneficial and thus they will be adaptive. They accumulate in the population, and because they accumulate in the population, what we have is the maintenance, okay? The maintenance of favorable genotypes. Is that following Hardy-Weinberg law? No, it is not. This is not good for Hardy-Weinberg, and thus we cannot have no natural selection. This is why we do not have natural selection, because this assumption gets thrown out the window because of the problem that leads to this adaptive evolution nonsense that goes against the Hardy-Weinberg equilibrium theory. And this is the idea of natural selection, and then we'll conclude our discussion on the Hardy-Weinberg conditions in the next video.